Assalamu alaikum, dear students. Today we will be discussing the factors affecting elimination reactions. Like in our previous lecture, we have discussed that when a reaction occurs, the course of the reactions is determined by some factors, that it will be a substitution reaction or elimination reaction, then also that it will be E1 elimination reaction or E2 elimination reactions. In the previous lecture, we have discussed the strength of the base, the nature of nucleophile, and the temperature. In this lecture, we will be discussing some other factors which are affecting the elimination reaction. The solvent effect. Solvent has also a key factor, key role in the determining the course of a reaction. Basicity is like nucleophilicity and can be affected by the nature of the solvent. The first effect of the solvent is that it affects the base or the nucleophile, because the nucleophile is present in the solvent, may be dissolved in the solvent or may be a two-phase reaction. If the solvent stabilizes the base too strongly, its energy will be reduced, and by the Hammond postulate, the reaction will be slow. A stronger base is closer in energy to the activated complex, which lowers the activation energy and giving a faster E2 reaction. Like in the previous lecture, we have seen that the stronger bases were up and closer to the activated complex. And when they are closer to the activated complex, so the activation energy will be lower. Lower amount of energy will be required to get to the activated complex, and the reaction will be faster. What is the activation energy? As we know that activation energy is the energy that a substrate must have to attain before a reaction may occur. A weaker base is further in energy to the activated complex, which raises the activation energy and giving a slower E2 reaction. That is, like in the previous lecture, we have seen that graph in which the stronger bases were near to the activated complex and the weaker bases were further away down to the activated complex. So if they are down or further from the activated complex, more activation energy will be required to get to the activated complex, and so as a result the reaction will proceed slowly. Since it is the base that matters in E2, solvents that do not stabilize negative charge give faster reactions. Those solvents which are stabilizing the negative charge of the base will have a rendering or hindering effect on the procedure of the reaction, and the reaction will be slow. But those solvents that do not stabilize the negative charge, they will give faster reaction. Like SN2 reaction, the E2 reaction proceed at much higher rate in polar aprotic solvents. Why? These are the polar solvents, In a polar protic solvent, the base is stabilized as the solvent makes partial bonds to it, like here. This is a protic solvent, water. It has stabilized this base. The anions are heavily solubilized, solvated, and they have a bond with it, and it is the anion is stabilized in the polar protic solvent. But against to this, the aprotic solvent, the base is not stabilized. There is, you can see, no bonding between the base or the anion and the solvent. The anions are weakly solubilized in the aprotic solvent, and they are free to attack the substrate. And so the reaction, the E2 reaction, is faster in a polar aprotic solvent as compared to polar protic solvent. Now we will come to the role of the leaving group. As since the leaving group is involved in the rate determining step of both E1 and E2 reaction, in general, any good leaving group will lead to the fast elimination. In both the E1 and E2 reaction, the leaving group is directly involved in the rate determining step. So the better is the leaving group, the faster will be the reaction. The slower is the leaving group, or not efficient is the leaving group, the slower will be the reaction. Here, this is a quaternary ammonium ion. This is a good leaving group, and we get 81% yield. The same is the case. We get 98% yield. The hydroxyl groups can be turned into good leaving groups in acid, but this is only useful for substrate that can react by even elimination. The hydroxyl group is never a leaving group in E2 elimination, since they have to be done in base. A strong base would remove the proton from the hydroxyl group instead. Hydroxyl group can be a good leaving group in the E1 elimination, but in the E2 elimination reaction, it cannot be a leaving group. The reason is that in E2 reaction we use a strong base, and the strong base can remove, instead of hydroxyl, the hydrogen, the proton from the hydroxyl group. For primary and secondary alcohol, the hydroxyl is best made into a leaving group for elimination by sulfonation with para-toluene sulfonyl chloride, normally called tosyl chloride, or methane sulfonyl chloride, methyl chloride. So these can be made a good leaving groups by the reaction with the tosyl chloride or methyl chloride. And again, OH is never a leaving group in E2 reaction. A good leaving group will lead to a fast elimination. A stabilized tertiary cation could be found, but no strong basis present, so the mechanism must be even. Here, see this reaction? There is no strong base, so it must be an even elimination reaction. Effect of the leaving group on E2 reactivity. This is the order that if we increase leaving group ability, the rate will be, E2 reaction rate will be increased. Iodine is a good, iodide is a good leaving group as compared to bromide. Bromide is a better leaving group as compared to chloride, and chloride is better than fluoride. The fluoride is the most difficult leaving group, or it is not a leaving group in the E2 reaction. Then the polar solvents, polar aprotic solvent, increase the rate of E2 reaction. That we have discussed earlier in the earlier slides, that how the aprotic solvents increase the rate of E2 reaction, because it solvate the base or the anion not completely. It doesn't completely solvate the anion and not stabilize the anion. So it is ready for attack on the proton. Structure of leaving group. Look at to this reaction. Here a primary bromide, secondary, tertiary, and the comparative rate will be, for primary it will be 1, for secondary it will be 4.76, but for tertiary it will be 40.5. So the rate of elimination increase for is most for tertiary, then medium we can say for the secondary, and lesser for the primary halides. Substrates with leaving groups on primary, secondary and tertiary carbons can usually undergo E2 reaction quickly. Why? Protons are typically well exposed on primary, secondary and tertiary substrates. If you see here, in the presence of a strong base, the rate of elimination or the chances of elimination are more. The reason is that the proton is more exposed for the attack from the base. And so more is the proton exposed, more it will be attacked by the base. The chances will be that a base will attack it easily, and the chances of elimination are more. A leaving group must live in the rate determining step on an SN2, SN1, E2 or E1 reaction. The leaving group is involved in the rate determining step. Never mind, it is an SN2 reaction, SN1 reaction, E2 reaction or E1 reaction. So the ability of leaving group directly affects the rate of a reaction. The identity of the leaving group has an effect on the rate of each reaction. Every leaving group has certain effects on the rate of the reaction. A good leaving group is necessary for the reaction to be exothermic and spontaneous via delta H. The leaving group ability strongly affects the E2 reaction. As we have discussed that better is the leaving group, better will be the E2 reaction, because the leaving group is directly involved in the rate determining step of the reaction. Here, these are the substrate that readily eliminates by E1 reaction. Tertiary halide, stabilized carbocations, and we would get a elimination product. allylic products, they are stabilized and we get elimination product. Benzylic, ethereal substituted, again the carbocation is stabilized and we get the E2 elimination, we get the elimination reaction. Now these are the substrates that may eliminate by E1 reaction, the secondary one. Because the carbocation is less stable and it may eliminate by E1 or may not. And these are the substrates that never eliminate by E1 reaction, the primary one. Why? Because the carbocation is very much unstable. Like here, the tertiary one, the carbocation was quite stable, in allylic also, benzylic also, and in the ethereal also. The carbocation was the stable one. But in secondary, there are chances depending upon the presence of other groups. But primary will never undergo even elimination reaction. Reason is that the carbocation is very much unstable. Polar solvents also favor even reactions because they stabilize the intermediate carbocation. Like in the previous slides about the solvents, we have discussed that it stabilizes the base, the protic solvents may stabilizes the base more and it will be not available for the reaction. Similar is the case that the solvent, the polar solvents also favor even reaction because it stabilizes the intermediate carbocation. More is the carbocation stabilized, more will be the even reaction. Elimination from alcohol in the aqueous or alcohol solution are particularly common and very useful. So here there is one difference, that the polar aprotic solvents favor E2 reaction, but the polar protic solvent will favor E1 elimination because it stabilizes the carbocation. Thank you very much for your patience. Thanks a lot. Thank you.